What is the main problem addressed in the paper regarding pre-training datasets for large language models, LLMs?
The main problem addressed in the paper regarding pre-training datasets for large language models, LLMs, is the challenge of determining the optimal strategy for mixing datasets that come from Common Crawl, CC, and smaller domain-specific sources. The paper highlights that previous works have struggled with balancing between using heavily processed CC data and more domain-specific datasets, leading to limited disclosure of information on pre-training data contents in most modern language models. Additionally, the paper emphasizes the difficulty and cost of validating data mixing strategies at a large scale, resulting in a lack of open research on pre-training data for LLMs. The authors propose a novel approach called domain upsampling, which involves modifying the data mixture at the end of training to improve LLM pre-training data mixes in a cost-effective manner. This method aims to address the challenges of optimizing data mix proportions and characterizing the impact of individual datasets on model capabilities without the need for exhaustive training runs.
How does the domain upsampling strategy proposed in the paper improve the performance of the language models? Provide a detailed explanation of the process step by step.
The domain upsampling strategy proposed in the paper improves the performance of the language models by strategically adjusting the data mix proportions at the end of training. Initially, a baseline mix of publicly available datasets is used, which includes large-scale Common Crawl, small-scale Common Crawl, domain-specific data, and code. This mix is based on a heuristic for the number of epochs each dataset group would be seen during training. Then, during the last 20% of training, domain upsampling is introduced by modifying the data mix proportions. This involves increasing the representation of domain-specific and code datasets while removing large-scale Common Crawl. The rationale behind this is to bias the model towards token distributions with high information density in domains of interest. The domain upsampling intervention significantly boosts model performance on challenging benchmarks such as GSM-8K and human eval by approximately 10 percentage points higher than the baseline model. This improvement is attributed to the inclusion of high-quality domain-specific data and code-related datasets, which enhance mathematical and programming abilities. Importantly, this performance enhancement does not come at the cost of general language modeling capabilities. In fact, it leads to an overall improvement in model performance as measured by Gauntlet V0. 3 Core Average. The domain upsampling strategy effectively improves world knowledge, as indicated by enhancements in MMLU and the Gauntlet V0. 3 Subset Scores, bringing the model closer to the performance of the Llama 2 7B model. Furthermore, by adjusting the duration of domain upsampling, the researchers were able to navigate the trade-off between targeting specific domains and general language modeling capabilities. Through experiments varying the percentage of training time allocated to domain upsampling, it was observed that increasing the fraction of training with domain upsampling beyond 20% led to improvements in math and coding benchmarks at the expense of general language modeling abilities. This highlights the importance of strategically timing and balancing domain upsampling to achieve optimal performance across different types of benchmarks.
What are the specific improvements observed in the metrics MMLU, GSM-8K, and human eval due to domain upsampling compared to the baseline data mix?
Domain upsampling led to improvements of up to 90 percentage points pp on MMLU 8, 26 pp on GSM-8K, and 17 pp on human eval compared to the baseline data mix.
How is the success of domain upsampling method demonstrated in navigating the trade-off between targeting specific domains and general-purpose language models?
The success of the domain upsampling method in navigating the trade-off between targeting specific domains and general-purpose language models is demonstrated by conducting experiments with varying durations of domain upsampling towards the end of training. By ablation experiments, it was shown that increasing the fraction of training with domain upsampling beyond 20% led to improvements on math and coding benchmarks at the cost of general language modeling abilities. For instance, while math and programming-related benchmarks continue to improve with increased domain upsampling, other benchmarks like MMLU and Gauntlet V0 3 core average peaked at 10% and 20% respectively. This trade-off indicated that the data mix proportions used for domain upsampling were not definitively better than the initial data mix for overall model performance. Therefore, the domain upsampling method provides a flop-efficient tool to strike a balance between enhancing specific domain capabilities and maintaining general language modeling proficiency, allowing researchers to explore this trade-off effectively without the need for full training runs.
Can you explain the experimental design for domain upsampling at the end of training and how it impacts the model capabilities with discussions on specific datasets?
The experimental design for domain upsampling at the end of training involved starting with a checkpoint at 0.8 tokens of training, changing the mixing proportions of the pre-training data mix, and continuing training for the remaining 0.2 tokens. The domain upsampled pre-training mix focused on emphasizing domain-specific data and code subsets while removing large-scale common crawl. The percentages for domain upsampling were chosen based on the hypothesis that emphasizing high information density domains at the end of training would benefit the model. This intervention significantly boosted model performance on challenging benchmarks, particularly on math and coding tasks, with scores approximately 10 pp higher than the Llama 2 7B model. By removing subsets of math-heavy pre-training data during domain upsampling, the impact of these datasets on specific benchmarks was quantified. The results showed that these specific datasets were crucial for improving mathematical knowledge and reasoning capabilities in the model. This approach allowed for a cost-effective way to measure the impact of pre-training datasets on model capabilities at a scale where difficult tasks could be reliably assessed using fewer training flops. The domain upsampling method provided a tool to navigate the trade-off between targeting specific domains and general language modeling abilities, demonstrating the efficacy of targeted changes to the data mix at the end of training in enhancing model performance on specific tasks.
What are the implications of the study's findings on the efficiency and cost-effectiveness of conducting pre-training data experiments for large language models, according to the paper?
The study's findings suggest that domain upsampling at the end of training is an effective and cost-efficient method to improve pre-training data mixes for large language models. By modifying the data mixture towards the conclusion of training, significant performance boosts were achieved on challenging benchmarks, such as GSM-8K and Human Eval, without compromising general language modeling capabilities. This approach allowed for achieving performance levels comparable to models trained for twice the number of tokens, but at approximately half the training flops. Additionally, the study demonstrated that domain upsampling can be a flop-efficient tool to analyze how individual datasets impact model capabilities, providing insights into the importance of specific subsets of data. The findings indicate that even simple heuristics for selecting new data mix proportions can have strong positive effects, offering room for further improvement with better-tuned mixing proportions. Overall, the implications of the study's findings suggest that domain upsampling can make pre-training data experiments more accessible, cost-effective, and efficient by providing a method to navigate the trade-off between targeting specific domains and enhancing general language modeling capabilities.